Okay, well, I think I'll start to kick things off. So, hello, everybody, and welcome to today's technical discussion. My name is Christy Duncan, and I will be your host for today's session. Today, we're going to be talking about the NPD closure project's draft environmental assessment follow-up monitoring program. And while we've been tracking public input on the program for the past couple of years, the goal of this session is really to solicit additional feedback from you all on the project's monitoring program. So we really want this to be a dialogue between yourselves and us. And before I go any further, I'd just like to acknowledge that the NPD closure project is located on the unceded and unsurrendered territory of the Algonquin and Anishinaabe people. And this is important to acknowledge in the context of today's discussion because the NPD closure project is part of CNL's environmental and stewardship mission, and CNL recognizes First Nations, Métis, and Inuit as stewards of the land. So not only is it important to acknowledge that connection, it's also important that we meaningfully engage with them to ensure that the project continues to be protective of the environment for generations to come. So today's session is part 2 and is focused on groundwater monitoring, our groundwater monitoring plan. So I want to go over a couple of housekeeping items. So this session offers simultaneous interpretation, and what that means is that you can access this session in both English and French. There is a globe icon at the bottom right of your Zoom bar. So simply select the language that you would like to hear, and there you go. There is a slight lag in translation, so we just ask that you wait until the full translation is complete before speaking. And today's session is really all about hearing your thoughts and questions and concerns. We want to hear from you and have a wholesome dialogue. So we've structured this session for a presentation that will take about 30 to 45 minutes. And then the rest of the time is dedicated to a discussion. And with that said, we would encourage you all to ask questions at any time of the presentation. And in fact, we've incorporated prompt questions throughout the presentation for your consideration and input to help facilitate that dialogue. Also, during today's session, we just ask that you keep yourself muted if you don't have questions, just to allow other people to hear Juliet's presentation clearly. And just a note that this session is recorded, and we record this session so that folks have access to the presentation after today's session, and we do post them on our YouTube channel. If you do want to remain anonymous, that's completely an option. All you have to do is log out of the session, and then when you log back in, there's an option to change your name, and so you can change your name to anonymous if you would like. And we would really encourage everybody to feel free to speak up during the presentation or during the discussion session. And if you do have any technical issues, either during the presentation, don't hesitate to get in touch with us at ermstakeholder@cnl.ca. We do have a member monitoring that inbox, so we'll get back to you as soon as we can and get you all sorted out. Couple of participation guidelines, and I see some familiar folks from Tuesday's session, so this won't come as a surprise. These are participation guidelines that I think everyone could agree on, and they're really simple. Number 1 is that everyone has wisdom, and we need everyone's wisdom for the wisest results, which is why public input is so important on our plans and on our projects. Number 2 is that there are no silly questions. If you have a question that's related to the material, no matter how big or small, we want to hear from you. And number 3 is that everyone will be respectful of each other and everyone's time. So that means on this call, just use the hands up function. So that can be found at the bottom of your screen. There's a little smiley emoji, and it has reactions. So you just put your cursor over that emoji, and then just use the raise hand function. And with that, I would like to introduce you to our panelists. So from the NPD project, with us today, we have Katie Shorter, who is the acting regulatory manager for the NPD project. Hi, Katie. We also have Mike English, and Mike English is the facility manager and part of the engineering team working on the NPD closure project. We also have Juliette Louise, who is the project's environmental analyst. And same as last time, Juliette will be our main presenter for today's discussion. And with us as well, we have Martin Klukas. Martin is the section head for environmental assessment and impact, and he is part of our environmental protection team. So with that, I will pass things over to Juliette. So Juliette, take it away.
Thanks, Christy. Good afternoon. Today, I'll be presenting an overview of proposed groundwater monitoring activities for the NPD closure project. The purpose of today's workshop is to provide an opportunity for feedback about groundwater monitoring, and also to describe some feedback that we've received so far and how we're addressing that feedback. Just a note that when we do receive feedback and suggestions, so for example, requests to add monitoring locations or change monitoring frequency, we don't have a response right away. We take that feedback to our subject matter experts to really evaluate the justification for the change before deciding if the monitoring plans should be updated. So I will begin today with a brief overview of where NPD is located. I'll review the concept of in-situ disposal, which is the objective of the NPD closure project. I'll give some background on what follow-up monitoring is. I'll provide a general overview of the geology, hydrogeology, and groundwater quality at NPD. I'll describe at a high level the groundwater modeling that has taken place for the environmental impact statement. I won't go into a lot of detail here, but we do encourage questions if you want to discuss the modeling in more detail. Then I'll describe the groundwater monitoring plan for the NPD closure project, along with the feedback we've received so far and how we will be updating the monitoring plan. And then we will wrap up with a discussion session. And I believe there's a poll as well before the discussion session. So the NPD site is located along the Trans-Canada Highway, halfway between North Bay and Ottawa, and it's located on the south shore of the Ottawa River. The image on the right shows a zoomed in view of the site with the Trans-Canada Highway running across the bottom and the NPD main road that leads to the developed area of the site. The whole site is approximately 380 hectares and is mostly undisturbed forest. The developed part of the site occupies less than 1% of the whole property. NPD was the first nuclear reactor in Canada to put electricity to the grid. It operated from 1962 to 1987. It was the training center for many operators and engineers of the Canadian nuclear industry. In 1987, after it completed its mission to show that nuclear power could be used to generate electricity in Canada, the reactor was placed in a safe shutdown state. After that, there was a first phase of decommissioning, during which the reactor was defueled and drained. The fuel and heavy water were transferred to Chalk River. The non-nuclear components and structures that were no longer needed were removed, and the NPD reactor building has been in a safe shutdown state for over 30 years. So this slide graphically depicts what in-situ disposal is all about, and that's the method CNL is proposing to complete the decommissioning and closure of the NPD facility. The image on the left shows the current state of the facility. To give an idea of scale, the deepest part of the facility extends to almost 100 feet below ground within bedrock. The image at the bottom shows in-situ disposal in progress. The existing concrete structure would remain in place. Some of the concrete walls of the facility are 8 to 9 feet thick. The systems and structures that are currently in the facility would remain in the facility. Then the above ground structures would be demolished and placed in the open spaces of the facility, and then it would be filled with grout. There would be a small batch plant on the site to prepare the grout. The part of the facility that contains the nuclear structures would be covered with a concrete cap, and then the whole footprint of the building would be covered with an engineered cover system with vegetation on top. The end result would be a waste disposal facility at the NPD site. CNL believes that in-situ disposal is protective of the environment because it contains and isolates the contaminants within the grouted facility. The image on the right shows what the site would look like once demolition and grouting is complete. You can see that the stack will remain because it's a roosting site for chimney swift birds, which are a species at risk. So what is follow-up monitoring? Follow-up monitoring is a formal part of the federal environmental assessment process. The objectives are to verify predictions from the environmental impact statement, to ensure mitigation measures are performing as expected, and identify any unanticipated effects. To limit unanticipated effects by incorporating the concept of adaptive management, to incorporate Indigenous knowledge into monitoring activities. CNL is working very closely with several Indigenous communities and organizations to collaborate on monitoring activities. So there are 3 separate documents that describe monitoring activities, one each for effluent, environmental, and groundwater monitoring. And each of these are aligned to their respective CSA standard. The follow-up monitoring plans have been available since 2019, and we have been tracking feedback that we've received so far, and we will be revising the plans to reflect some of the feedback that we've received. The plans are in a draft state now and will only be finalized after an EA decision by the CNSC, because there may be additional monitoring requirements in the EA decision that we would include in the plans before finalizing them. So when does follow-up monitoring start and end? Follow-up monitoring begins essentially now, before the project starts, with collection of baseline data, which will give us a snapshot of current environmental conditions so that we have something to compare future monitoring results to. Follow-up monitoring will continue throughout the decommissioning execution phase, and that will last roughly 2 years. That's when the demolition, grouting, and installation of the cap and cover takes place. Monitoring would continue for the duration of the institutional control phase, which is a period of a minimum of 100 years, where active monitoring and surveillance will take place. It's important to emphasize that the duration of institutional controls is a minimum of 100 years, and regulatory approval is required before this phase can be terminated. And just a note on abbreviations, later on in this presentation, you'll see the decommissioning execution phase abbreviated as DE, and the institutional control phase abbreviated as IC, and that's just to save room on the slides. Now a brief overview of the geology and hydrogeology of the NPD site. The bedrock in the area where NPD is located is moderately fractured Precambrian gneiss, and it's part of the Canadian Shield. The black and white photo is a picture taken during the construction of the facility, which shows the excavation into bedrock. The Ottawa River and Quebec shore can be seen at the top of the photo. The overburden is glacial till, comprised mostly of sands and gravel. It's approximately 2 meters thick by the Ottawa River shore and approximately 5 meters thick near the facility. The water table is just above the top of bedrock, with the overlying sands and gravels being largely unsaturated. The groundwater discharges to the Ottawa River. On the map to the right, the contour lines are water table elevation, and the groundwater flows perpendicular to the contour lines. I just wanted to point out the 2 pink shaded areas on the map. These are 2 old unused landfills. The landfill near the bottom of the map was used for cafeteria and office waste, and it's a closed landfill. And the one near the top of the map contains just rubble from the excavation for the facility during the construction days. So on the left of this slide is a photo, again, taken during construction of NPD. And you can see the Ottawa River and Quebec shore in the background. Here you can see the pipe trench that was excavated out of bedrock that leads from the deep excavation for the facility to the river. Water intake and discharge pipes were laid in this trench, and then it was backfilled. And those pipes are still there today. On the map on the right, that pipe trench corresponds to the solid green line. The pipe trench is considered a preferential groundwater pathway from the facility to the river in the groundwater modeling for the NPD closure project. And I'll talk a bit more about that in the next slide. So looking at the figure on the right, around the perimeter of the facility is a tile drain system. It's a perforated pipe that lies on the bedrock surface and collects groundwater and diverts it to the Ottawa River to keep the facility dry. There are two main outlets of the tile drain system, tile drain 1 at the top of the figure in red, and tile drain 2, which is the purple line on the right side of the figure. The groundwater model for the NPD closure project accounts for the pipe trench, tile drains, and overburden characteristics. And these are all shown conceptually on the bottom left figure. As part of the grouting process, the pipes themselves will be filled with grout from the facility to near the Ottawa River shore. Although these pipes will be filled, the trench itself will still be a preferential pathway for groundwater. The figure on the top right shows an example of how groundwater flows around the facility. The Ottawa River is at the top right of the figure. So this figure shows particle tracks of groundwater as it moves towards the river. You can see how the tile drains draw in the groundwater towards the facility, and then the groundwater moves on towards the river. Overlain on the particle tracks are the locations of groundwater monitoring wells. Those are the lighter blue dots. So you can see that the wells are placed within the zone where the groundwater that leaves the grouted facility flows towards the river. The figure at the bottom right is a conceptual cross-section showing the facility labeled NPDDF, which stands for the NPD disposal facility. So that's the facility after it's been grouted. The modeled discharge pathway from the grouted facility to the river is shown in purple. You'll notice an area of the cross-section labeled springs. There are no springs there now, but the groundwater model predicts that there could be springs arising between the facility and the river after the facility is grouted and becomes saturated with groundwater and the tile drains hypothetically fail. When the tile drains are functioning, they channel water to the river, and that lowers the water table. Once the tile drains fail, the water table would rise again and the springs may emerge. There were springs in this area prior to the construction of the NPD facility, so they may reemerge in the future. So for current groundwater quality at NPD, there have been several groundwater monitoring campaigns in the past at NPD in the 80s and 90s, and in more recent years up to 2018. These campaigns focused around the two landfills, around the NPD facility, and along the Ottawa River shoreline. Groundwater was analyzed for a broad suite of radiological and non-radiological parameters. There was a comprehensive study in 2014, and in that study, there were 2 wells with manganese exceedances above the Health Canada drinking water standards. But it was concluded that these are anomalous values and not due to contamination, because manganese is a naturally occurring abundant metal in the bedrock of the area, and natural manganese levels in groundwater can be up to 800 micrograms per liter. For context, the high manganese levels at the 2 wells at NPD were about 50 and 300 micrograms per liter. In terms of tritium results, the highest measured tritium was just under 300 becquerels per liter near the northern facility wall. Tritium along the shoreline averaged 65 becquerels per liter. And to put these values into context, the Health Canada drinking water limit for tritium is 7,000 becquerels per liter. So overall, there are no groundwater issues at the NPD site. So here I'm going to have one pause for questions. So far we have covered geology, hydrogeology, and groundwater quality at NPD, and we've talked about the groundwater modeling that's taken place for the NPD closure project. Christy, I'm not sure if there's any questions that have come in.
Yep, so we do have one question coming in. So how long does it take a groundwater molecule to move from the NPD site to the river?
Yeah, that's a very good question. So we were asked this at an engagement event a few years ago, and we looked into it, and it thinks it's approximately 4 years for groundwater to move from the NPD site to the river. So that's my understanding. I'm not sure if anyone else on the team can add to that, but I think that's the value that I've seen. Yeah.
Looks good.
Any other questions?
Yeah, so no additional questions. Yeah, so as I mentioned, as we go through the presentation, if you do have questions that come up, don't hesitate to just put up your hand or type them in the chat, because that's really what we're after today. So I'll give folks a couple more minutes and then I'll turn things over to you. So it looks like we're all good for now. So Juliet, please proceed with your presentation.
Okay. Thanks, Christy. All right, so now I'm going to give an overview of the groundwater monitoring plan for the NPD closure project during the decommissioning execution phase and the institutional control phase. And I'll talk about the monitoring locations, parameters, and frequency. I'll review some recent changes to the monitoring, and I'll discuss the feedback we've received so far on groundwater monitoring. I'll give an example of the EIS prediction for groundwater quality, and I'll discuss how we will evaluate groundwater monitoring results. Then I'll wrap up by discussing how CNL incorporates adaptive management into the monitoring programs and how we will report our monitoring results. And then we'll end off with a poll and then another opportunity for questions and discussion. So this slide summarizes the plans for groundwater monitoring. Monitoring will take place at 2 wells up gradient of the facility. Those are the 2 blue dots at the bottom of the map. So these 2 wells will be used to determine groundwater quality before it interacts with the grouted facility. Monitoring will also take place at the wells between the facility and the Ottawa River. You can see those wells in the middle and near the top of the figure. Groundwater will be monitored for radioactivity and non-radioactive parameters of interest, including pH, mercury, lead, and PCBs. pH would be monitored because the grout is an alkaline substance, although modeling shows that no alkaline plume would emanate from the grouted facility. Lead would be monitored because there is lead shielding in the facility. And then for the other substances, there are very minor residual amounts in the facility. There are no significant impacts to groundwater predicted because in-situ disposal isolates and contains contaminants within the grouted structure. So this monitoring will be the way to confirm that prediction. The usual frequency of monitoring will be twice a year in spring and fall, but there will be certain times that we'll do groundwater monitoring 4 times a year just to get more data. So we'll monitor 4 times a year during the year that decommissioning is complete, and that will give us a snapshot of the groundwater situation right after project activities are complete. And another time we'll monitor 4 times a year is when the facility is expected to be saturated with groundwater, and that's predicted to be approximately 40 years after grouting is complete. In terms of baseline, we plan to start baseline groundwater monitoring this year, and then we'll continue to monitor groundwater throughout the decommissioning, execution, and institutional control phases. So now I'll describe secondary monitoring, or what's called triggered monitoring. So this is additional monitoring of the environment that would be initiated if we see unexpected monitoring results in the primary monitoring. So the primary monitoring is on the left of the screen, and then on the right of the screen is the secondary monitoring that would take place if required. So for today, I'm just going to focus on the first row at the top. If there is an exceedance in groundwater monitoring, it would trigger sediment monitoring. And a groundwater exceedance would also trigger soil and vegetation monitoring in the areas where the groundwater exceedance was detected. The concept of triggered monitoring links the three monitoring plans together, and that ensures that the relationship between groundwater, environmental, and effluent monitoring is taken into consideration. So now I'll talk about some recent changes.
Juliet,
Yeah.
before you continue, we did have a question come in to me directly.
Okay.
So participants, if you do have questions and you want them to remain anonymous, you can choose who you send the message to. So if you would like to send it to me directly, that's a great way to just remain anonymous if you would like. So this question came in, and this person was wondering, how did CNL select the locations of the ground monitoring wells?
So these, the wells that you see on the left of the screen, those were selected, they all come from a series of monitoring campaigns throughout the years. So some of them were selected, they were all selected basically on the groundwater flow path. And you can see more wells down by the river shore, and they're spaced to have regular interval to detect groundwater quality down gradient of the facility. I'm just going to ask if there's anybody else on the NPD team who has a bit more background on that. Each of the studies goes into rationale for the placement of the wells. So I don't know the rationale for each of the studies, but they were placed generally to capture groundwater that flows from the facility to the river. I believe Mike English can jump in and add a few things here.
Yeah, hi, Juliet. So what Juliet said is correct, and just want to add a little bit of extra detail there. So the idea is to capture water before it reaches a facility and then capture water again after it's passed through the facility. So the groundwater flow regime at site is roughly from 7 o'clock to 1 o'clock on the left-hand photo. So the wells were selected basically to catch the upstream and then the down gradient water as well.
Great, thanks. Anything else, Christy?
No, it looks like that both of your responses answered the question. So thanks, Juliet and Mike, and please proceed.
Okay, thanks. So, right, I am going to cover some updates to monitoring. We had the groundwater wells, the existing ones, inspected because we wanted to start baseline monitoring of the groundwater now before the project begins. Upon an inspection, it was found that the existing wells by the river were a bit too shallow and didn't yield enough water for sampling. The existing wells are the ones in blue on the left side of the slide. So to resolve this problem, a new series of wells was drilled along the river shore to replace these older wells. And these wells are on the diagram on the right side of the slide. So these wells are deeper and they're deep enough to consistently produce enough water for sampling. So some more updates. At the bottom of this slide, you can see that the same conceptual cross-section that I showed earlier in this presentation. When the original groundwater monitoring plan was written back in 2018, the modeling at that time didn't predict the potential emergence of springs. Because the possibility of a spring is not currently in the plan, we will be updating the document to include a sampling location at any spring that may arise along the slope between NPD and the Ottawa River. The figure on the right side of the slide shows the tile drain system around the facility. There was an investigation late last year, which confirmed low but steady flow of water in tile drain 2 on the right side of the figure. We'll be sampling the water in this tile drain as an effluent monitoring point, and we will be evaluating if a groundwater well should be installed in this area as well. So some feedback that we've received so far. We received some feedback that groundwater around the 2 landfills on the site should be monitored. In response to that feedback, we have comprehensive past groundwater monitoring campaigns which includes around the areas of the landfills. So these studies confirmed no groundwater issues from the landfills. So for the NPD closure project, groundwater monitoring is proposed to focus around the NPD facility itself. We also received a question why there are no groundwater monitoring wells around the full perimeter of the NPD building. So you can see wells up gradient and down gradient, but not on either side of the facility. The person who asked this question said that landfills in Ontario are required to have groundwater monitoring on all sides of a landfill. So for this feedback, CNL's response is that the groundwater flow regime around NPD is very well understood, and the wells are placed along known groundwater flow paths. But regardless, groundwater direction is a parameter that will be monitored, so more wells can be added in the future if monitoring results indicate a change in flow direction. Finally, we received a request to monitor vegetation once every 5 years during the institutional control period, even if there's no exceedance in groundwater. If you recall, we have vegetation monitoring around the groundwater monitoring wells as a triggered monitoring activity, which would take place only if there's a groundwater exceedance. So in response to this request, CNL believes that keeping the vegetation monitoring as a triggered monitoring activity is appropriate because the most likely way that vegetation would be contaminated is through groundwater. So groundwater monitoring would give the earliest indication of impacts to vegetation. So now I'll review some EIS predictions for groundwater. I'll describe how we will evaluate monitoring results and incorporate adaptive management into the monitoring program. So this slide summarizes the EIS predictions for radionuclides in groundwater. The assessment shows a peak of 5,000 becquerels per liter of tritium at the facility wall right after grouting is complete, and then it rapidly drops off. This is a very conservative assessment, and in fact, the modeling is being refined, and the tritium peak is actually expected to be much lower, on the order of 1,000 becquerels per liter right at the facility wall, and then still dropping off rapidly as groundwater flows to the river. And for context, the modeling shows that the peak tritium in the river itself is expected to be 0.04 becquerels per liter, which is an insignificant increase over baseline levels of tritium in the river, which is about 3 becquerels per liter. In terms of non-radiological parameters, lead is a non-radioactive parameter of most importance because there is a considerable amount of lead in the facility used for shielding. The assessment predicts a maximum of 4 × 10⁻⁶ milligrams per liter in bedrock groundwater. So this is extremely small and orders of magnitude lower than federal and provincial guidelines for lead in groundwater, which range from 0.02 to 0.1 milligrams per liter. So now I'll talk about how we will evaluate the monitoring results. We've set up a 2-tier system of data evaluation. The first tier will compare the results to the predictions of the EIS or to baseline conditions where no effects are predicted. The second tier will compare to limits, which include drinking water limits and provincial guidelines. So today I won't be presenting the actual values for tier 1 and tier 2 because the plans are from 2018, so quite a few years old, and the evaluation criteria will be updated based on more recent modeling for the EIS. This slide shows the actions CNL would take if there are exceedances in tier 1 and tier 2 values. So if tier 1 is exceeded, the monitoring data would be reviewed, the source of the exceedance would be investigated, and the monitoring frequency could be increased. Our monitoring documents didn't include the option of adding additional mitigation measures for tier 1 exceedance, so we got a question about that. This is actually a standard practice at CNL, but it was missed in the documentation, so we will be adding that response action under tier 1. If tier 2 is exceeded, we have the response actions listed on the screen. For tier 2 response actions, we got feedback that CNL should not wait for a tier 2 exceedance to occur in order to implement these response actions, because tier 2 values are federal and provincial benchmark and guidelines. So to be clear, CNL would implement tier 2 response actions well before benchmark or guideline values are exceeded. Tier 1 exceedances would give a very early indication of unexpected monitoring results and would trigger response actions. So CNL would not wait until benchmark or guideline values are exceeded before initiating whatever response actions are necessary. And just to clarify, we're not expecting to see any values that come close to benchmark or guideline values. So all of CNL's monitoring programs are dynamic in nature. We're continually assessing our programs through a number of mechanisms and continually improving and adapting the program based on changing circumstances. Some of the main ways that we improve our programs is through day-to-day evaluation of the data and adaptive management. CNL performs annual data assessments looking at trends throughout the past year and determines if any changes are required, for example, a special investigation based on those trends. There's also an annual full program review, which looks into the program design to ensure that the program is still adequate and effective and meeting our objectives. So this review could result in actions like updated monitoring locations, frequencies, and parameters. And reducing monitoring frequencies, parameters, or locations would require appropriate justification, which would be documented. So monitoring of data, the data would be analyzed as the results are obtained, and we will be reporting the results to the CNSC on an annual basis, and the results will also be available to all interested parties. So that was an overview of groundwater monitoring activities for the NPD closure project. CNL has aligned all the monitoring plans with the respective CSA standards, which outline a very systematic method of developing monitoring programs. CNL will be transparent with the monitoring results and will incorporate adaptive management techniques to ensure that monitoring remains meaningful through time. So we continue to seek feedback on these plans, and we're working very closely with several Indigenous communities and organizations to ensure that monitoring from an Indigenous perspective takes place and that Indigenous knowledge is incorporated to ensure protection of the environment. These plans are draft and they will continue to evolve, and we won't finalize the plans until we receive an EA decision on the NPD closure project so that we can include any additional monitoring requirements that may be specified in the decision itself. So the last slide here is for discussion, but I believe before we go into the discussion session, we are going to be having a poll. So I'll hand it to Christy for that.
Thanks, Juliet, and thanks for all of that great information on groundwater monitoring. I know I certainly learned a lot from the presentation. And as Juliet mentioned, we are going to be launching into the discussion portion of today's session. And to kick things off, we do have a poll for everyone. So let me get this going. I'm going to launch a poll. It's going to pop up on the center of your screen. So I'll be launching that now. And for the poll, it's 2 questions. We want to know, did the presentation help your understanding of the environmental assessment follow-up monitoring program for the NPD closure project? So it's a yes, no, or undecided. And the second one is, did we provide the right level of detail on NPD's draft plan for follow-up groundwater monitoring? Because we want to know how we're presenting the information to you. Is it effective? So there are 3 answers available. There's not enough, just right, and too much. So I'll just give folks a couple more minutes, and I believe I can also share the results as well. Okay, it looks like everyone has participated, so I'm going to end the poll and I'm going to share the results. So now on your screen, you should see the results of the poll. For number 1 question, did the presentation help your understanding of the overall environmental assessment monitoring program for the NPD project? You all answered yes, it did. And for the second question, did we provide the right level of detail? And people said yes, it was just right. So thanks everyone. I'll stop sharing and you may just need to click the X button on the poll just to exit out. And we also have a couple of discussion questions for you guys today. We want to know and we want to hear your feedback on the monitoring locations that we've selected for the groundwater monitoring. Are they sufficient? Were there any places where you felt we should be monitoring that we're not? What about the monitoring parameters? Do you think we're monitoring for all the right parameters? What's important to you? The frequency of monitoring. Are we monitoring enough? Does it make sense for the amount of times that we propose to monitor? We also want to get some feedback on the tiered method of evaluating monitoring results, as well as our response actions for unexpected monitoring results. So this is a great time. Feel free to unmute yourselves now if you want to just shout out a response or a question. That's perfectly okay too.
And I'll just add that the presentation today was relatively high level because there's so many topics to cover. But if there's any willingness to get into in depth about any particular topic, we're offering to organize one-on-one meetings on specific topics where we can discuss one topic in depth. So if you're interested in having this kind of meeting, you can contact us through the email on the screen, ermstakeholder@cnl.ca.
That's right. And it looks like we have one question coming in. So this question is about mitigation methods. So could CNL provide an example of a mitigation method that they would use should a high level of a contaminant be detected in the groundwater?
Sure. So the main mitigation method for groundwater is the containment and isolation of the contaminants in the facility, and that's called an in-design mitigation measure. We also have contingency plans that we can implement in case we do see an exceedance of groundwater, and this could be a pump and treat system, for example, installed between the facility and the river. So we don't have specific contingency measures developed because the contingency measure would depend on exactly what we're seeing. So during the annual review, we would review the results, and if required, we would discuss the appropriate contingency plan to implement. And also at Chalk River, there's a considerable experience implementing this type of groundwater treatment. So we have that kind of expertise in CNL. And just to reinforce that, we don't expect to see any kind of exceedance that would warrant a contingency measure like groundwater treatment.
Thanks, Juliet. There weren't any follow-up questions to that. I don't see any other questions from anybody on the call today. But if you do have questions after the presentation, don't hesitate to get a hold of us through ermstakeholder@cnl.ca because we do want to hear from you. And we really value the input that you all provide. So please don't hesitate to reach out. So we'll give folks a couple more minutes and then I'll go into closing, but this is really a great opportunity to ask the experts on the call about anything to do with groundwater monitoring or the project. We're just going to check in. Okay, well, if there are no follow-up questions for the NPD team or the environmental team, I will close the meeting. So we will be sending out any responses that we receive to questions that came in to ERM stakeholder at cnl.ca. And if you do want a one-on-one session with Juliet and the NPD team, please don't hesitate to let us know, and we'd be happy to set that up. Just a reminder that we welcome any feedback, and because ultimately that informs the environmental monitoring program. So I hope you all have a great rest of the day, and hope everyone has a great long weekend, and I hope you all stay happy and healthy. And I look forward to seeing you all at the next session. Okay, take care, everybody.